So a couple things to get out of the way. This is like province. From the province, this is what they want. So let's say you have a fraction like this, and you're either asked to state it in one of these three formats, because probability can be stated in these formats. Words is the easiest one, 1 out of 3. That's kind of cheating, but that's okay. Right? You're not writing 1 and 3 in words, but that they would accept that. But now follow this part, 1/3. So I would say you divide that in your calculator, 1 divided by 3. And I'm going to pretend like this section here is what you see on your calculator. And I think some of you already know where this is going, right? But let's say you have the 0.33333 on your calculator. I will tell you this. This is just a trick of the trade. Because it's not money, okay guys, it's not money, I'm going to state my decimal and I'm going to round it to 4 decimals. And why am I going to do that, you think? Because I take that number and I multiply that by 100 to get me 33.33%. Right? So I state my decimal as I round it to 4, not to 4. Then multiply that by 100 to give me this. And the reason being is a lot of students would do this on the provincial exam. Let's say it's like, hey, state it as a decimal. They stated this. And that is actually correct. But then now as a percentage, they would just say, well, it's 33%. And the province says you rounded too soon, right? So you're technically always supposed to go back to this when you're stating everything, right? Always back to the original. So be careful there. Let's do another one. 2 divided by 7. So you go ahead and divide that. I picked numbers that 5, 7, 1, and that keeps going, right? So I kind of pretend like I'm writing everything down here. And then the decimal, help me out here. 2, 8, 5, 7, right? Because the 1 doesn't affect my 7, so I write it down like that. When I see you graduating on June 30th, you walk on that stage. Before you graduate, I'm going to hold this up to you. It's like, what is this? Rounded to 4 decimals, right? And only then can you graduate. That's just a joke, but maybe I'll do it. They'll think I'm crazy, right? Percentage, 28.57%, right? And then words, I go back to the fraction 2 out of 7. Done. Okay, so we got that out of the way. The best way I know how to do this is round this to 4, just times that by 100, and then you're done. You'll never get it wrong, except for if it's a dollar amount, then you will. This would not be acceptable, right? Okay, so I can almost guarantee that you'll have a chart like this on the test or quiz or both. So how do you do a chart? I will do the easiest one. So let's say you're getting this decimal. Let's turn it into a percentage. So you just take that and multiply it by 100. And that gets you 19.2%. I'm getting us ready for probability, okay? Previous skills here. Prior knowledge. How do you turn that into a fraction? Oh, this is how you do it. Follow me. These are the tens, right? Hundreds, thousands, right? So there are 192 thousands in this number right here. So what I will say to you is this. There are 3 decimals, right? Therefore, 3 zeros. Right? So the number of decimals tells you how many zeros you're going to have in your denominator. Okay. Next, this one. You are given a percentage. To bring it into a decimal, you will want to divide by 100. That gives you 0.3575. We use all of it. Okay. And then you want to turn that into a fraction, so you just recognize 4 decimals. So you go 1 followed by 4 zeros, and then just put that exact number on here. 3575, like that. I'm not reducing fractions yet. We're going to do that a little later. So we just went 4 zeros, right? And if you're really not trusting me, you're like, I don't know about this. I don't know about this. I'm going to check it, right? I'm going to divide these two. And hey, it's that, right? It's that decimal here. So many ways of double checking, triple checking, okay? Next, you have a fraction. Can you do this? Can you fill in the rest as best as you can? I will go over it in a bit. I'll just do my attendance. You should be able to. And his dad died at a very young age, so you have to take over. Very, very difficult upbringing. So sometimes when we think we have it bad, just looking at what other people had to go through helps, right? So we divide this, and we get 780 what? 6, that's right, because there's a 9 next to it, right? There we go. So that's 78.06%. No problem. Which way do you want to go here? It's up to you. You want to go left, right, whatever. 1, 2, 3, 4 over 1, 2, 3, 4 zeros, right? Like that. Boom, done. And then here you would just multiply that by 100 and just get that. So when it's decimal, you can go, it's easy to go either way. Okay, we're good. Next page. Let's do some reducing fractions. It's not going to be very heavy, reducing fractions. I'm not going to dwell on it too much, but we are supposed to remind you how to do it. So I will. All right. The easiest way to simplify fractions is to divide both the numerator and the denominator by the same value. You keep doing this until you cannot find another common number anymore. The fraction is then called simplified. So some rules that help me. If the number ends in an even number, then the whole number is even. So you'll be able to divide it by 2, guaranteed. Okay? If the number ends in 0, it is divisible for sure by 5 or 10. Okay? If a number ends in a 5, well, then it's for sure divisible by 5. And if the sum of the digits is divisible by 3, then the whole number can be divided by 3 also. What are you talking about? Well, let's talk example, right? 573. 573. What do the digits? You're like, it's not even. I can't divide it by 5 or 10. It doesn't end it at 0. So let's see here. 7 and 3 is 10, right? So these digits add up to 15, right? If you go 7 plus 3 is 10, plus 5 is 15. So this one is divisible, right? Divisible by 3. That's what you've just discovered. So if you have a number and you're not sure, hey, can 3 go into it? Just add up the digits and then you find out for sure. Okay. Okay, so let's do a couple here. You can already do everything if you want, if you know how to do it, but I look at both of them, they're even. So I'm going to divide this by 2, divide this by 2. Half of 28 is 14. Half of 42 is 21. 1 ceases to be even here, so I can't use 2 anymore. Can I use 3? Well, 1 and 4 is 5. 3 doesn't go in there. 7, right? Some of you are like, it's divided by 7, Mr. Erickson. I know that. So that'd be 2 over 3. That would be considered fully simplified. Let's say you're like, I don't know about that. I don't know if that's right. You go 28 divided by 42. You get 0.66 repeated for this one. 2 divided by 3 gives you the same, right? So that way you know for sure you got it right. Let's do more. Both of these are even, so I'm going to go divide it by 2. Divide it by 2. It's 25. 72 divided by 2 is 36. And now what? This is divisible by 5 only. You can't do 5 here for sure, so that's it. You're done. Can't go any further. These are not even, correct? And not. So I'm going to do the 3 check. 8 and 4 is 12. 2 and 1 is 3, plus 3 is 6. Aha, I can divide them both by 3. So I'm going to go divide by 3, divided by 3. You should be able to do mental math, but if not, if everything else fails, you just go and divide it like this. So 71, 28 divided by 71. 1 is even, 1 is odd, so 2's don't work. Add it up, this is 8. 8 cannot be divided by 3, so 3 wouldn't work. You're done. Okay, you're done. And then this one, try it. See what you get. Maybe you won't fully simplify. That's what you should be getting. So I decided they're both even. Slice it, right? Make it smaller, then it's easier to see what you can do next. And then I added up my digits. I decided 3 goes into both of them. And then I was stuck now, right? That's as far as you can get. Okay, that's it for simplifying. You will see some here and there, but let's keep going. I need to review deck of cards. I'm going to give you a very short version of a deck of cards. Okay, how many cards are there in a deck? In a standard, 52. It says it right here. So we take the jokers out, right? Did you know that casinos, they punch a hole through their decks, right? That way you can't use them again. Anyway, so a deck of cards, very important for you to know what's what. So just write some of the things down that I'm going to say here. So obviously 52, and you split it in half. 26 reds, 26 are black, right? So half and half. We have our 4 suits. Clubs and spades are, right, 13 each. 13 in each suit. right? And so clubs and spades are black, hearts and diamonds are red. There are 12 face cards, right? So every suit has 3 face cards, Jack, Queen, and King. So in total, there'd be 12 face cards. Half of them are red, right? Sorry, black in this case, and half of them are red. From number 2 all the way to number 10, we call those numbered cards. So write that down, right? So these are numbered cards. So 2, 3, 4, 5, all the way to 10. And these are our aces, right? 4 aces. So if I were to say, what's the probability of drawing an 8, for example, I'm actually talking about all 4 of them. If it's an 8 of clubs, there's only 1, right? If it's a black 8, there are 2 of them, right? So just make sure you know how many am I talking about. So here's a short version of a deck of cards. I'm going to just make that right here. You can make it even smaller, but I'll just say this. You have something like this. 52, 26 are black, 26 are red. And then from there you branch off and you say there's 13 clubs, 13 spades, 13 hearts, and 13 diamonds. Okay. Some of you can make this fit on my fingernail probably. Your writing is so neat and you're able to compress it. And this is optional, but I will add it. And so you have ace, 2 to 10, and then you have jack, queen, king for every single suit, right? Jack, queen, and king. Ace, 2 to 10, jack, queen, king. So forth. So I don't know if you need it for every single one, but that is, I think this is too much space, to be honest, for your study sheet, but now you know kind of what it looks like, and then you can compress it even more. I used to just dive right into cards, and some students needed to visualize a deck of cards, right? So, and others play cards all the time, so you're like, I don't need it, right? So it's up to you. Whatever you need to do to be successful, right? Page 5. So writing down, so just wait a bit. Page 5. Here it is. Now we're starting a bit more. This is more like the meat and potatoes of today's lesson. Probability. Probability is the likelihood of an event happening or occurring. Usually we state probability as a fraction, and therefore probability of an event. So usually in brackets we just put down what we're finding it for. Is number of favorable outcomes over, watch this is the key word here, total possible outcomes. Very important. That is what probability is all about. The total possible outcomes go at the bottom. And I'm gonna, before I dive in, I want to introduce you to a concept that is so important yet so simple. So imagine this is all of it, 100% chance of something happening. But if somebody says, right, let's take a quarter of this pie, and somebody says, There's a 25% chance of snow. That's what it says there, by the way. 25% chance of snow. What is it also telling us? What is this part that is not the 25%? This is saying that there's a 75% chance of it not snowing. Okay? And always, both of them are always 100%. Okay, guys? So if there's a 13% of something happening, then there's an 83% chance of it not happening, right? And so always remember, combined, it's always 100%. 2 out of 5 people text while driving. That means that 3 out of 5 people do not, right? So keep that in mind. Here we go. Probability of event happening, which is PE, right? Plus probability of event not happening, which is PE. But you see that bar? Make sure it's very clear. That is in math. That means not. Some of you might take courses in college or whatever. That is not. Okay? So it happening, it not happening, always adds up to 100% or 1. And here, E bar or E with an apostrophe means against, not happening, right? So right now, don't let the formula scare you too much. I think it'll make sense to you. But if you want the probability of an event happening, you could go 1 minus it not happening. Or if you wanted to know the probability of the event not happening, you just go 1 minus it happening. So like if it's 25% chance of snow, 1 minus 0.25 would give you the percentage of it not happening. You're with me, right? And here's just a statement that's very important. A fair game gives you a probability of winning of 50%. That would be considered a fair game, that you have a 50% chance of winning it. If there's a 0% chance, it's impossible to win. It can never happen. And if something ever ends up being 100%, it's certain that it will happen, right? So just to have a bit of a reference, fair, no chance, certain, right? Okay, let's do our first example. There are 20 students in Mr. D's class. This is the total right there. You will not always have the total. They might say, the question might say, you know, might list a whole bunch of things. You have to come up with the total. He knows that 7 of those students are driving to school. A, state the probability of a random student driving to school. So in my class, if I were to just randomly pick, what are the chances that I would pick a student that drives to school? It has to be random for this to work, by the way. Probability of driving, this is normally how we state it. P of driving is 7 out of 20, just like that. So 7 divided by 20, I'm going to use my calculator. That's 0.35 or 35%. Yes, I separate them by a comma if I'm asked to state it in all 3 formats. See how it says here, fraction, decimal percent? Don't put equals, 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 because quite often it is not. You're rounding, okay? B, what is it asking? Probability of a random student not driving to school. We all agree that it's 13, right? 13 do not drive if 7 drive. But watch what I'm going to do here when it's a not. P driving, what am I going to do with that? I'm going to put a bar on top like that. Just fancy, right? So watch what I'm going to do here. This might be like, why are you going to do that, right? But trust me, this is the way to do a not. You go total minus driving, right? There's 7 driving. So not means like, hey, take them away. Take them away from the total over 20. So that gives me 13 over 20. Trust me, this is going to be handy later on. The minus. And that gives me 0.65, which is 65%. And there you should see, hey, it happening, right? Somebody driving, somebody not driving adds up to my 100%. Probability, we do not have more than 100%. That is only when like you want to say like the crime rate has risen by like 300%. You can say that. But you cannot say anything more than 100% for probability. Okay? You can't say there's a 400% chance of you being sick tomorrow. You can't say that. You can only say 100 max. Right? Keep going. I'm going to let you do a few of these here. So watch this, guys. Watch what it says here. Total needs to be determined, right? So you need to figure out, it's saying here, consider the spinner below. What's the probability that will land on red? You need to be able to read it that way. What's my total here? Well, you count. 1, 2, 3, 4, 5, 6, 7, 8. Total is 8. Okay? Total outcomes, total possibilities is 8. So when you come to your probability, you should have an 8 there every single time. Probability that it lands on red. How many reds are there? 1, 2, 3. There are 3 reds there. So I'm going to go 3 out of 8. Turn that into a decimal. This one ends, right? It's fixed. So it's easy. So there's a 37.5% chance of you landing. So let's say this is a game at Red River X. Hey, if it lands on red, you would win a prize. This would be considered, this is not a fair game, right? Because it's less than 50% chance of you getting it. Okay? So just giving you a perspective. And most games aren't fair because they want to make money. Okay, I'm going to let you do the rest. And I'm coming back to correct it. So give it a try. Remember, there's the bars, the knots. And one more here, guys, before you start. Green or yellow, when it's or, add them up. Right? You can add up those favorable outcomes. So you go for it. Take a few minutes. I'm going to correct it. Probability of yellow. There's 1 yellow out of 8, which translates to this, which translates to that. Blue, I counted 2. Let's reduce that one, shall we? 1 out of 4. I think you can handle that. It's 25% chance. That means not getting blue would be 75%, right? So just always keep that in mind. Probability of not yellow, watch how I do this. I go 8 and I'm going to count how many yellows there are. I know from before that there's 1 yellow. So that means that not getting yellow is 7 out of 8. And that gives me 0.875, which is 87.5%. You should be able to ace this tomorrow, okay, guys? When I give you that AC on this. Probability of not getting red, I'm going to go 8 minus, I'm going to go find reds, and there's 3 of them. So that gives me 5 out of 8. And that is 0.625, which is 62.5%. It's very interesting stuff, eh? You're all excited. Can't wait to tell your friends. Green and yellow, right? 2 greens and 1 yellow. That is actually 3 out of 8. Now that you have more options, right? The or in math represents the plus, okay? This or that, well, it doesn't matter then. Let's just say 3 out of 8. And there's a 3 out of 8 way at the beginning, so I'm just going to go off of that. Okay, blue or red? I have 2 blues and 3 reds. That's 5 over 8. That's 0.625 and 62.5%. Okay. Let's go crazy here. I'm gonna add something. I hope you can do this one. What if, pay attention, what if I asked you to do this? Green or yellow, but I put one of these on top. No, it's not a problem, right, guys? Because what are we gonna say? Green or yellow? Green or yellow, we had 3 options, right? So we're gonna go 8 minus 3 because we don't want these 3. So that would be 5 over 8, which is 0. Right here, 625, which is 62.5%. Oops. Say what? So probability of yellow or green is 37.5, but it not happening is 62.5. What should these add up to? 100%. That's right. That's right. I think the not is not being emphasized in the younger grades, to be honest. Right? Should always do both, right? That's really what it is all about. 20% chance of something happening. Oh, okay, so 80% of the time it's not going to happen. When we stated, watch this, guys, making predictions. Maybe highlight that. This is going to come up quite often. Making predictions, okay? I can predict that it's going to happen down the road. Just hang in a little bit longer. I'm almost done. I promise. When we state a probability, we can use it to make a prediction. We are essentially, stay with me, extrapolating or forecasting what should happen on a greater scale. Have you ever heard of this word before? Extrapolating, extra, you're going outside, you're going beyond the data you're seeing. Anybody heard this before? You've heard of it? I can promise you that after today, you'll hear it at least one more time in your life. When you're listening to the radio, whatever, it's like, oh, extrapolating, I remember that word. So that's what the government does all the time. They have data and they want to extrapolate. They want to kind of predict what's going to happen in the future, right? And plan accordingly. This needs to be on your formula sheet. This is how you make a prediction using probability. Okay? You take the probability of that event and you multiply it by the greater sample size. That's how they do polls. That they poll people on a smaller scale and then they assume that's going to be the case on the greater scale. As long as the poll is done correctly, like you can't just do Instagram or Facebook, like you gotta go phone people, right? The older folks, they have their landlines still, right? So you gotta kind of like mix it up and find a good mix, and then you can predict based on that. So here we go. If you were to spin the spinner above 350 times, how many times would it land on yellow? So it's like they're asking you to predict. So you're gonna say probability of it landing on yellow on the small scale times sample. So what's the probability of it landing on yellow from up there before? Go up and look it up. 1 out of 8, right? And we're told that we're going to spin it 350 times. I'm going to play this game 350 times. So you grab your calculator maybe do it, right? 1 divided by 8 times 350, 43.75 times. We can't have that, right? So you would say this, approximately 44 times. Or 43, it's up to you. Some might argue, let's not say 44 because it's not quite 44, so let's round down. As long as it's a whole number, you're good. How about if the wheel was spun 199 times? How many times would you expect it to land on red? So here, we will predict, we'll go probability of red times sample. So how many, what's the probability of it landing on red? 3 out of 8. So you're basically saying, if you were to spin it 8 times, it would land on red 3 times. And now you're asking yourself, well, what if it would be 199 times that I would spin this thing? So you go 3 divided by 8 times 199, 74,625. Can't have that, right? So approximately 75 times. That's your homework. You go home, make a spinner. No, I'm just kidding. It's not gonna happen. I have better things to do than that, right? I'm just gonna trust you on this one. Well, it might be that you need to spin it 1,000 times for it to actually be quite accurate, and we'll talk about that as well. Keep going, guys. I'm gonna skip page 7, but I will show you. Go to 7 first. I'm gonna skip it. I'm gonna assign that once I'm done. This one doesn't have a total, so you need to figure out how many total chocolates there are. Okay? So this is kind of the trick here. Let's keep going. It's like a spinner, but instead of having sections, you have chocolates. Okay? Let's go to page 8. I will not finish 8. I will do the first 2 or 3, and then I'm going to let go. Okay? You're with me, right? Okay. I hope so. Consider a standard deck of cards. That's 52. State all probabilities in 3 forms. State the probability of drawing a 5. So you go like this, probability of drawing a 5. We know we have 52 cards. How many 5s are there? There are 4 5s. Right? Every number shows up 4 times. 4 5s. Comma. We're going to turn that into a decimal. 4 divided by 52. Watch that. It's a small number, but that's okay. 7 6. What does that 9 turn to? Does it stay 9? The answer is yes. It stays. Okay, it stays. You take that number, multiply by 100 if you want, and make sure you get that right. So if I were to give you a deck of cards, like a random shuffled, well shuffled, and I just said, you know, draw a card, draw a random card, there's a 7.69% chance that you would actually get a 5. Okay? What's the probability of drawing a face card? There are 12 face cards. And that would turn out to be, your chances are actually going to be higher, right? Because you've got more of those. That's 0.230. Remember, you want to graduate. I hold this in front of you right now. 23-0. 8, right? That's 6 bumps to 7 to an 8, which is 23.08. One last one. State the probability of drawing a numbered card, not a face card, or an ace card. I forgot to add that. So you don't want the ace, you don't want the faces, right? You just want the numbered cards, like 2, 3, 4, 5, 6, 7, all the way to 10. How would you do that one? Can I show you? I would do this. I would go 52 minus 12 face cards, like I don't want them, right? Minus how many ace cards? There are 4 aces, right? So 52 minus 12 is 40. Minus 4 is 36 numbered cards. You can remember that from now on and just know there are 36 numbered cards. How many of those are red? Half of them, right? Half of them are red, half of them are black. So remember, probability of numbered would be 36 over 52. That's 0.6923 or 69.23%. Okay. Do this in class so you don't have to worry about it, but I'm going to tell you to do 7 to 10. So page 7 we just skipped. I want you to do it. All of that remains with 8. Page 9 is a blank page, so you don't even have to do it. Page 10 is just basic simplifying fractions and filling in a table, which should take you, some of you will take less than a minute to do. So I will post the key to this, and that concludes today's lesson. So just remember everything we've done. Maybe add stuff to your study sheet when it comes to prediction, not stuff like that.